Welcome to the fourth lab in this series. In the last one, we had learned how to fine tune like a grandmaster. And in this one, we'll learn how to prepare your data set effectively. So in this notebook, we will explore how to do data preparation for downstream NLP tasks. And this is a list of non-exhaustive tasks where you can utilize these techniques or use this knowledge. And what we'd like to do now is sort of do this programmatically in Python and then see how Data Studio allows you to do this very easily. So let's import all the relevant libraries here. We'll use PyTorch, Transformers, Pandas, NumPy, and Matplotlib. The dataset here is a collection of LinkedIn influencer posts, and these were collected, I believe, in 2021. So let's import it to the S3 bucket and let's take a look at its tail, see what's inside the dataset. So you can see it's printed out the tail of the dataset. I can see the name, number of followers, time spent, the content, the media type, if there's an image or not, the link of the image, and here's the content of the post. So all of these have, I think, a good amount of metadata around the posts by all of these influencers, right? I believe these would be the number of reactions and comments. So you can see a lot of interesting posts here, I believe. So I personally spent some time reading through this data set. I encourage you to do that. But you can see it has about 34,000 examples. And here's a summary of the entire data frame that we've just loaded in. So there are about 70 influencers in this data set, and let's plot all of their names, see how many times they've posted. I don't think I recognize many names here. Maybe you do. But these are all of the influencers that have posted in this data. I know Simon Sinek. That's one person I know. So here you can see their names and how many times they've written on LinkedIn. What we're going to do now is sample 100 out of this. So we'll randomly sample their names, headline, and content out of this. So from here on, we'll write a few custom functions to do a few things. And what we're going to do first is remove all profanity or threshold all profanity to 90%, which means posts that are less than 90% profane are going to go through. So you can see we've imported from this nice framework that someone has created called profanity check. And we'll get the probabilities of how profane the content is and then sample for everything that's under the threshold. And we'll then collect those posts right here. You can then plot a histogram of all of these. And also take a look at a few examples right here. The next thing we'd like to do is do some quality checks. So here we've come up with a way of filtering using Flesh-Grade reading level. Flesh-Kincaid or Kinsard grade level is a very sophisticated number that comes out between 2 and 10, and you can read through this formula to understand it. But what it does is it gives you a simple number after doing all of this calculation that corresponds with which grade student should be eligible to read it. So if it says a number is 3, a third grader should be able to read it. So we can use this quite conveniently to our advantage to filter out from our data set, right? So what we're going to do now is import textart, and we'll set the minimum level to 2 and maximum to 10. Then we'll write out a helper function and then filter between these two grades. So that again furthermore cleans up our example, and we can take a look at the histogram of all of these flesh grades across the data set as well. So after this, we've sort of created this entire pipeline, right? So we'll write a few more helper functions to remove any trailing white space, to do a check of the maximum length and keep the relevant columns. So we'll keep the maximum length to 10,000 and minimum length to 1. We'll set the profanity to 0.9 and the minimum grades between 2 to 10. And then we'll run this entire pipeline to get our final cleaned data set right here. And we'll run this across the entire data set now. So it says we lost about 37% of our data set while cleaning this further. And to go a step further, maybe let's only select based on reactions. So let's select the top most reacted post since we want to go for the most popular post. We'll do that now. So that leaves us with about 2100 top performing posts that are not profane, have a good quality, have been cleaned up properly. Now we're going to use H2O GPT to do more smart content generation, so that using this great content, we can now have more content and thereby have infinite content. What we're going to do is utilize H2O GPT to provide a title for our LinkedIn influencer content. And since we are not giving any examples, this then becomes a zero-shot example. Please note you might have to change these URLs a little. Always keep an eye out along the course notes to make sure you're doing this correctly. So we'll set the links and the keys to H2O GPT. From there, we'll ask it to generate a title. So here's the prompt we're providing it. You're a helpful, respectful, honest assistant that specializes in generating titles of posts. Please provide a title for the following post. It should be a single sentence and not bullet points. So let's go ahead and run this. And then print out the content. So here is the content that we're sending it. And let's take a look at all of the titles it's returned. So now is a good time to pause and read through it. I'm not going to do that. Alternatively, for fine-tuning, you can also create an instruction. So remember, for fine-tuning, you always need an instruction and an answer. The way to do that is you can sort of create an instruction that says, hey, create a post in the style of this person. Here is the clean headline, and it can be described like so. So this is one way to sort of reverse engineer the fine-tuning by actually giving the prompt yourself, and then you can fine-tune using this. At this point, you can now use H2O GPT to run over the entire data set and have it give titles of every single post. This might take some time, so this is a homework for you to only run over a few examples. Maybe try it yourself. But from here, let's see how you can do the same using LLM Data Studio and do it very effectively. So let's jump to that environment. Again, look at the course notes on instructions how to access this. So Data Studio is a tool for doing the same task earlier, but with a focus on LLM. So you'll see it has a lot of nice to have features as well. It follows this 3 philosophical steps, so to speak: curate, prepare, and augment. So the first step is to curate your data set. Here you can upload your files, you can import them, you can also put in the web page URL, and you can define the task type right here, depending on what you're trying to solve. This is the step where Data Studio takes in all of these different file formats and then converts it into question answer pairs, on which you can then directly fine tune a model if you'd like. So many people forget this part, but you have to start with data that's never in the format of question answers. Data Studio takes care of all of that and automatically creates these question answer pairs for you. So part of your homework is to upload some documents here and see how that behaves. Let's take a look at some examples here. So what happens inside the preparation step? Let's click next. And remember all of these steps earlier we had done with helper functions by defining them manually. You can see here, you can simply create this flow that takes care of all of those steps. So I can clean the data set, I can augment it, I can remove profanity, remove personal identifier information, do quality checks, and all of that stuff. So if I hit configure, you can see the cleaning steps, the profanity check steps, the length filtering, the text quality checking that goes on here. So all of the settings we had defined earlier are done here, and we get the output in a nice CSV format. So when I click review, it gives me an overview of this entire pipeline. And then I can run the pipeline to get the CSV file. Once I've done that, I can then finally augment these with my own input data sets, or simply view them right here as well. So you can see this is the output that comes out of this step. So this is Data Studio that does a lot of these data prep steps automatically. Please understand that with LLMs, the pipeline is ever so slightly different, and that's why it's important enough to have this independent app in itself. Once you play around with this, you'll understand there are a lot of fine details, a lot of special ideas in here that make it very easy to work with data prep for LLMs. And that is your homework for this lab, so to speak. To upload your own documents, change the settings, see how it behaves, see what outputs you get from there. And once you've done that, we'll come to the final lab, which is learning how to evaluate your own LLMs. So evaluating all of these ideas we've been working on so far.